Look at the heavy, intricate materials surrounding you right now. The iron pumping through your veins, the gold resting on your finger. Yet, if we rewind to the moments immediately following the Big Bang, none of this existed. The early universe was a vast, empty expanse, comprised almost entirely of two simple gases, hydrogen and helium. This creates a massive cosmic discrepancy. How did an environment made of nothing but a single proton and its closest cousin manage to manufacture the dense, heavy matter that forms the Earth today? To understand how this transformation occurred, we have to look for the subtle traces left behind in the light of the early universe. To study the past, we rely on a mathematical delay. Light races at 670 million miles per hour, but space is fast. When observing a distant galaxy, its light has taken millions of years to reach our telescopes. We are literally looking backward in time. The primary tool used to analyze this ancient light is spectroscopy. In the early 19th century, scientists separated sunlight with a prism and noticed strange black lines interrupting the familiar rainbow. They realized that when light passes through a specific element, that element absorbs a very specific wavelength of color. Those missing colors appear as dark gaps in the spectrum. This diagram shows exactly how astronomers use these gaps. Every element creates its own unique pattern of spectral lines. They act as literal barcodes, allowing scientists to scan the light of a distant star and identify exactly what chemicals are inside. By reading these specific patterns, we can measure the exact makeup of the cosmos at different points in its history, tracking the origin of matter without ever leaving Earth. In 1929, astronomer Edwin Hubble pointed telescopes just like this one at distant galaxies and found an anomaly. The chemical barcodes were all there, but every single line was shifted toward the red end of the light spectrum. This animation illustrates what Hubble deduced. The light is stretched into longer, redder wavelengths because the galaxies are receding. The universe is expanding, meaning everything in the cosmos was once densely packed together. Around the same time, astrophysicist Cecilia Payne-Gaposchkin used these same techniques to prove that stars are composed almost entirely of hydrogen and helium, rather than the heavy rocks and metals found on Earth. Stars are massive, active concentrations of the universe's simplest, oldest ingredients. They represent the first step in the chain that leads to everything else. Over millions of years, gravity pulls vast clouds of hydrogen gas together. The heat builds until the mass violently collapses and ignites. Inside the newly born core, temperatures soar. Normally, positively charged hydrogen protons naturally repel each other, but the crushing pressure of the star forces these particles so close together that they overcome their resistance. This diagram demonstrates nuclear fusion. Extreme pressure causes hydrogen atoms to violently smash and fuse, forging a heavier element, helium. As hydrogen depletes, the core contracts, slamming helium nuclei together to forge carbon. It then climbs the elemental ladder, fusing oxygen, silicon, and eventually iron. A star is a locked, unconscious cosmic factory, relentlessly forging the dense, heavy building blocks required for planets and life deep within its burning core. But the factory has a fatal flaw. Once the star builds up iron, the fusion process permanently stops. The outward energy that kept gravity at bay is suddenly gone. In a fraction of a second, the core collapses under its own weight, causing a catastrophic explosion known as a supernova. The sheer chaotic force of this exact explosion is the only environment extreme enough to force particles together into the heaviest elements on the periodic table, like silver and gold. This image of supernova 1987A gives us observed proof of the wreckage. The explosion cracks open the core, scattering the newly forged elements across space. This enriched wreckage drifts through the cosmos for millennia, acting as fertile seeds for the next generation of planetary systems. Gravity eventually goes to work on these fresh clouds of heavy debris. The dense materials clump together to form solid, rocky planets, going far beyond the simple gas clouds of the early universe. The dirt you stand on, the rocks beneath the surface, and the oxygen in the atmosphere are all constructed directly from the carbon, iron, and gas forged in those ancient explosive factories. And the process extends all the way to biology. The complex molecules forming your skin, your bones, and the blood running through your veins were manufactured the exact same way. The history of the universe is written into your own biology. Every breath you take and every cell in your body is a continuation of a process that began inside a dying star. You are quite literally living, breathing stardust.